Hello, everybody. My name is Vladimir Sitnikov, and we have Andres Sacco here. Hi, Andres.
Hi, Vladimir. How are you?
I'm good. Thank you. Yeah, Andres is Java developer. Andres writes code, tests code, writes book, and delivers presentations. So that's nice to have Andres here. And before we begin with the presentation, can I ask you a little bit question? Like, typically, when it comes to the performance, it is often the database to blame. Do you think it is the same in your experience?
Yeah, most of the developers only think that the problems with the performance are connected with the latency, or perhaps you introduce a bug, but never anyone think about the problems on the database or the queries that you execute. So the idea of this talk is show you how you can prevent or reduce the risk that something bad happen when you write a query until that you deploy on some environment.
Yeah, that's nice to hear. I mean, it is also nice to have tests to cover some specific things you care about.
Yeah.
Go
ahead. Yeah. Sorry. It's the idea more or less that you have the possibility to check if you do something bad on your queries, because you test everything inside an application, the business logic, the controller, the transformation of the information, but anyone think okay, I write a bad query that introduces a lot of performance on my database.
Yeah, that's right. Nobody writes bad queries on purpose. So it's not like I'm writing a bad query because I want to make it bad, right? It just happens. Yeah, that's nice that we have tools that enable us to not only detect bad queries, but to assert on some specific features of the queries the application will use. That is a useful technique to have in your toolbox. So yeah, really looking forward to seeing the talk. But before we begin, I would suggest don't forget to ask questions on the Telegram chat during the presentation, and come back to the discussion zone after the talk to clarify things you didn't get, or you have more depth question. So yeah, I think we are ready to go. Let's begin.
Let's start with the presentation. Hi everyone, and welcome to this talk about Houston. We have a problem with the queries. And perhaps the title sounds funny for you, but the problem behind the scenes, it's not funny. Let me introduce me. My name is Andres Sacco. I work as developer since 2007 using different languages. Most of them are connected with the JVM like Kotlin, Scala, and Java. Also, I use in some projects Groovy and Clojure. I participate as technical reviewer on some of the biggest editorials around the world, and I publish for some editorials books, courses, and some theoretical practical exercise. Some of them appear at the bottom of the presentation. And last, I participate on different conferences around the world. Most of them are on Latin America. And at the left of the presentation, you will find my contact information, my LinkedIn, my email. So if after this presentation, if you have any doubts, any question, or something that I don't cover, and you want to know more information about this particular presentation, just send me an email or contact me by LinkedIn, and I will try to help you as soon as possible. So let me give you a problem, the context of a problem that appeared recently. You have a microservices which have some performance issues. So an endpoint takes more time to respond. For some reason, your endpoint, which takes 1 second to respond a common HTTP request, increase the time to respond to 5 seconds. Of course, you deploy a lot of features, but you don't know which of them produce the problem. Increase the use of resources. Again, the main problem with these kind of things is, depending on the language, you have more uses of the resources. In the case, for example, of the JVM languages, most of them create a thread, which implies that the use of more CPU, more resources allocated during the life of this HTTP request. Increase the latency in all the platforms. Imagine that your microservices is used for many others around the company or around the world. If one of them takes more time to return a response, all the other microservices will affect in some way to response. So it's not a simple, okay, I will take 1 or 2 extra seconds to give a response and nothing happened. And in a distributed architecture, it's not simple to find a problem. Again, because you have different microservices, different layers, so it's not simple to say, this layer or this class or this file had a problem with the performance, and it's simple to fix the problem. Okay, you have a problem, and how you can find the problem? Well, first you can create an end-to-end to check the entire logic and detect where you can more or less understand that there is a problem, on which of the flows the problem exists, or on which microservices. And perhaps you find it, which is great, but not with a great level of detail. So the next kind of test that you can do is create a performance test that check what happened with one particular endpoint if I increased or decreased the number of requests or for a period of time, just in case that for some reason, if I have 200 or 1000 requests at the same time, perhaps the performance decrease, and perhaps with 2 users or with 5 users or 5 HTTP requests, everything works fine. Okay, again, you know that perhaps the problem is connected with the number of requests, but know which is the problem or where is the problem. You can use an APM like New Relic or ALK to check the trace and understand on which of all of the microservices that have a flow have the problem with the performance, consume a lot of resources and consume a lot of time to give me an answer. So you reduce the entire picture or entire flow just in one part, one microservices, which is great. And the other approach could be add some logs on your application on each layer, so more or less you know on which of all of the layers that compose one microservices you spend a lot of time to give an answer. Okay, everything looks fine, but why this approach could fail? Well, because it's difficult to find. Imagine that you have a lot of microservices, a lot of layers, and a lot of new code that you deploy each day. So it's not so simple to find a problem on this biggest universe of things that compose a distributed architecture. It's difficult to understand why this happened. What is the reason that the behavior change or not change, perhaps in some cases, and why this increase of the use of memory on CPU and the time to give me an answer, why this happened? Because I don't change a lot of things. I change, I don't know, this class or this query, but nothing more. It's impossible to understand. And here is the key point of this presentation. Okay, I detect a problem, I fix it, I deploy in production, everything works fine. But how I can prevent that this happen again? Because this could happen many times if I don't have a mechanism that I put on the source code that give me an alert, like a test, and that, okay, you will decrease the performance, or you will introduce many bugs which increase the use of resources. And there are some tools that give you this kind of information with different levels, but the most relevant are for JFrogUnit, QuickPerf, Gatling, and Gmeter. And Gatling and Gmeter are similar, so I put in the same column as a particular category. So to detect a problem on the performance, all of them cover with different levels of detail, with different level of information, but you have the possibility to detect a problem on your application. Of course, with Gatling and Gmeter, you do just a big number of HTTP requests to one endpoint and check the response. And the other libraries like JFrogUnit and QuickPerf, you have the possibility to include in your application or in your library and do obtain certain information that is not the same with Gmeter and Gatling. Simple to implement, all of them are simple, it's not so complex, it's not like it takes 2 weeks to add this kind of test. And here is the main reason why QuickPerf is the best alternative on this kind of problems. Is give you the possibility to check if the queries are okay or not. If I don't do, I don't know, a lot of selects to find a particular information, or I do a lot of insert in a bad way to save the information in my database, or if this query takes a lot of time to execute it. So in this case, the winner is QuickPerf. Okay, but perhaps there are other reasons to use it. And have a big level of detail on more than one language. JFrogUnit and QuickPerf give you the possibility to include in your project on projects that use JVM like Kotlin, Scala, Java, Clojure, Groovy. So you have the possibility to include the library inside of your project and write a specific test to detect some particular problems inside of your source code. Gatling instead not give you the possibility to include in a project and check some particular part of your application. So it's like I can do a lot of HTTP requests and check the response time, but nothing more. Support many libraries to do testing or create your application. The winner in this case is QuickPerf, give you the possibility to combine QuickPerf with other libraries like JUnit in the case of Java. You can use it with Quarkus, with Spring Boot, which are frameworks to create application, and Hibernate, which is an ORM, and many others. In the case of Gmeter, which is agnostic to the technology, so it's not give you the possibility to interact with some framework, because it's not the idea, it's agnostic, you can run outside of your application, so don't make sense. And in the case of JFrogUnit, you have the possibility to use it just with simple, like in a Java application, with any interaction with other frameworks. And running outside the application, the winner is Gatling and Gmeter. because it's not necessary that you include in your application. You can have your different scenarios with different kind of tests, and you can run outside your application. But again, you don't have a lot of detail about the problem, so it's not the best alternative when you have a problem that you need to identify in particular on which section, on which layer of the application you have a problem. So the pros and the cons to use QuickPerf. Well, show you where is the problem, on which part of the application. You can validate the number of queries that you execute at the same time. Imagine that you want to check, okay, in this method or this class or this function only need to execute one select or one insert and no more. Integrate with other frameworks, as I mentioned, like Spring Boot. There are other ones like Quarkus and Hibernate. Check the consume of the resources. Imagine that you want to check if this method in particular, which access to many tables or many things in the database to obtain something, not allocate a lot of memory. But you have problems. Not everything is good. You need to access a database, a real database. So in some way, because you will check how works the layer that access to the database, you need a database with information, with tables. So in some particular way, you need to access a database that exists in some environment like stage on production, and which is the problem with this kind of things is you could not create a test that is idempotent. And so imagine that you create a test that insert a row inside of the database, yes, and have a unique value. The first time that you run your test, everything looks fine, everything works, because you don't have a row with these characteristics, with this information. The second time that you run or try to run the test will fail, because again, you try to insert some information with some particular data that exists in the database, so an exception will appear. So with this tool, with this library like QuickPerf, you need to find a way to solve these particular problems, like connect with a database, and that give you the possibility to, in each interaction, in each time that you run this kind of test on a pipeline, everything continue working. So let's show you an example. Here is the source code. You will find everything that I will show you during this presentation here. Let me show you briefly which exists inside of this repository. It's a README file which contains a lot of information about the requirements that you need to have in your machine, that the version of Java, Maven, Docker, how you can run the application, where is the documentation, because there is a Swagger with all the different endpoints to check, some frequent questions, and you will have here this repository, this directory or folder will contain all the source code of my endpoint. And the other one will contain a set of performance tests, because the idea of this presentation is show you attempt by attempt how I can find more information about the problem and how I can create that kind of test that give me the possibility to detect in the future a problem on my application. And here is a make file with a set of commands and to run the integration test, the performance, or run my application. And the application looks like this. It's a simple application which have a CRUD to insert or retrieve information about a city. So if I put a real city or a city that exists, this is the result, the name of the city, the country information about this city and the continent. If you put something that not exists, you will find an error. So everything it's okay for now. And let's move to the folder, to the directory I clone. So let me run the first attempt is like performance is run a performance test with the idea of, okay, give me some clues about the problem on this particular endpoint and why this happened. Perhaps something appear on the logs, perhaps something appear on the result. Okay, this takes more or less 20 seconds because it executes many requests at the same endpoint. And after that, you will find some information. Here more or less are the information about the number of requests, the mean response time, the max response time, and the percentile how many requests takes this explanation, 200 milliseconds. The 50% need to take this. And you have here in this folder, you will have the information in a way that is more interesting. Let me show you just a second. Okay, you will have something like this. It's a Gatling. Let me increase the size. Okay, you will have this. It's the same that appear on the console, but with a huge level of detail. Like you have a distribution of requests, how many requests at this per second takes, but you don't find any problem. Let me show you. You don't find anything that you consider, okay, this could be an excellent idea and to find a problem. So it's not the best alternative. So I will stop my application, which is running. I just will run start. No, I will do it in a different way. So the next step is, okay, I want to put more logs on my application to find where is the problem. So I have a file here, and I will change the level of to debug, and I include on the different layers of this application how many milliseconds takes each of these layers. So it's the second attempt. I will go directly to the endpoint. I just start, and this command let me I don't change, sorry, use Java. I don't change the version of Java, which is so important. And this will combine the entire source code and try to create a Docker file and run the application in an agnostic way. So I have my Swagger here, and I will try to execute again. Okay, let me show you, and you have this information. And this is the second. And when I change the logs, also appear this, which is the query that are executed. So if you saw, there are two queries to obtain all the information that appear on this response. So you have a clue about where could be the problem with these queries. So everything looks fine. I will stop because I have some information about which could be the problem. And as you remember, during my presentation, I mentioned it that the main problem with these kind of things is find a way that you can reuse the database. So each time that I run my integration test or this kind of test, not affect in some way that if exists or not previous information. So I can run many times without any problem. So to do this, I need to use containers, because if you remember, you have with containers you have the possibility to create many of them, and without thinking in, okay, I have the information persisted in some environment. So if I use container, I can create the database, run my test, finish the execution of my test, stop the container and drop the information. And the next time do the same. Create the container of a database, create the structure of the tables and everything that I need to use, run my test, finish the test, the execution of test, have the results, and drop the container, drop everything. And to do this, there is something which is called test container, and I will show you. You need to open the POM file, which contain all the dependencies of my project. So at the end of this, I will include these two dependencies. The first one is like the core of the execution of this container, will manage all the life cycle of the Docker containers. And in this case, you have the possibility to include some modules or dependencies that manage some specific containers. For example, there are a lot of them that manage the different databases like MySQL, Postgres, SQL Server, and other ones. So you not need to think, okay, I need to wait until that I have this log that everything is okay on my database to run my test. You delegate in some way to this container with this dependency to say, okay, let me know when everything is okay and I will start to run my test. If you not use this kind of mechanism, you will do it manually, and it's not the best alternative. And as you remember, we need to use QuickPerf, and QuickPerf have two models. The first one, this one, is the core of QuickPerf. So give you the main annotation, the main logic to find different kind of problem. And the second one give you the possibility to interact with certain frameworks. In this case, this application used behind the scenes Spring Boot. So for that reason, I include the dependency of Spring Boot. And I need to specify which version in particular I will use. So I will include at the top of my POM file these two dependencies. And just in case that something bad happened, I will reopen this project just in the directory, which contains only the source code of my application. So I include both libraries, which are great. I will reload my dependencies just in case. But I need to start to create my test because everything looks fine, but it's time to create. So I will create package okay, which contain the classes about city repository test. And what is this city repository? It's a test about this particular interface. Spring Boot create like an abstraction where this layer have the responsibility to access directly to the database. So behind the scenes, you have all the methods to access into the database, like the default insert, the default update, delete, and select by an ID. You have the possibility to use it extend it to this interface. And of course, you can override this default method, create another ones, which in this case I create a delete, and I create a find by code. It's like select everything from this table, this city table, and by code, where code is equal to this. And I want to create a test to this. So the first thing that I need to do is I need to run the entire context of my application. And so I need to include this. So I will start my entire application in a random port, and after that I need to check something. The second one, I need to include the annotation of test container, because I will tell you on this class is, okay, I want to use containers to check something on my database. The next two annotations on this text are connected with the QuickPerf. This one is connected with, I want to check the performance on some part of my application, but this layer access to the database, so I want to check the performance on the queries. I will fix the problem with all the imports. Okay, next problem. I need to declare the variable that represent, or the instance that represent this class. So I declare in this way. So when the application starts using this annotation, we'll create an instance of this layer, of this repository. Next problem, I need to create a database. So with this class, I create a MySQL database which use this Docker image, this specific version, with this username, this password, with this name of the database, and here is something so interesting. This with reuse, the idea of this with reuse is give you the possibility, if you have many tests on your application, and if you have many tests, the main problem is, okay, I start my container, run the test, finish the test, stop the container and drop it. And the next class, do the same. Many times doing this, you spend a lot of time, time to execute the entire set of tests. So test container give you the possibility to tell to all the other tests that include this test container annotation and declare the same container to, okay, the first one of my test that have this kind of information will create the container, start the container, will execute my test of this class, stop the execution of this test, and if detects that there is another class that need to use the same container, not stop, pass the information to the next one. So then the second test will not start a container, like connect with the existing one, run the test, finish the execution of the test, and if there is no more tests that need this container, we'll stop it. And you need to add some kind of configuration. Sorry, This one is like before all the execution of my test. This one is something bad. You need to start the container, and the stop the container is delegate to this annotation and to iterate with many other, with the other tests. And you need to declare these properties, like which is the URL, the user, and the password of my dynamic test. So let me show you a simple test, which is not something like something strange, because this kind of, sorry, I need to include all these things, if not something bad will happen. So this is a common JUnit test, so which only check if exists or not a city using the test annotation, nothing strange. And you need to start to declare something like, okay, I will to analyze this on this layer, the queries that are executed. The first thing is like expected selected. Is this annotation represent how many requests I want or I expect that this repository will execute after they execute this test. And okay, everything looks fine, and I want to run my test. How I can run is like, it's a simple command like mba. Oh, it's the same. Sorry, I use Java. The same problem again. Sorry. Okay. This will start the container. It's so quickly on the logs, but you find you see that there is a MySQL version, and here is the problem. I execute my test and I detect a problem because I expect that are executed one query, one select to the database, but in fact there is two, which is the same that we detect when we run the test and our attempts manually, and you saw there are two different selects. And here more or less are some clues about how to solve the problems, and here is the queries that are executed. Other things that you can do is like you can explain or tell to your test how many milliseconds takes to execute this particular method. In this part you have a lot of detail, and in some part of my test where here are the information about the execution of QuickPerf. The time to execute was, I don't know, in this case was 1 millisecond, but the threshold is the baseline to say, okay, if something takes more time than 2 milliseconds, I will produce an exception. I put 2. And if I run again, only will fail this assertion, because you combine the assertion on the test, which are all of these, with this one. So I only have one failure, and it's the same of the previous one. One of them passed, and everything it's okay. So, okay, great. And what happens if I want to check if the inserts work fine or not? Because the selects are okay. I can do the same with the insert, and the answer is yes, you can do the same. And it's like you have a different annotation for each time of operation, like insert, select, delete, and update. So you have the possibility to use all of them. Just in case that you want or you ask, the idea of this talk is not show you all the possible answer or the possible solution to this kind of problem. The idea is you have the possibility to create the test and send the test or push the test in some branch and contact with the developers and say, okay, I detect a problem, try to fix it. Or contact with the DBA or something like that. And I will run again. And I will start to recreate or create something more just to service. Okay, one of them failed in the case of insert, that when I want to insert one row, I just execute one insert and takes less than 1 millisecond. And what happened if I want to check in a different layer that do more things? Imagine that I have a layer that access to the database to check something if a city exists or not, and after that, if not exists, try to insert. So you have two different operations. So it's more or less the same structure as the previous one, and I will copy and paste this kind of information. Okay, and what else? Yeah, the properties. And I will show you another thing. Okay, this service layer is the responsible to contain all the business logic. So in my case, I want to do a select, and it's like the equivalent to this test. It's like the same, but in a different layers of my application. So I need to include the annotation to declare that it's a test or not. And in this case, I will do the same. I change, because I know this will execute two queries. If I not, I can put that there is one. And in this case, I want to do a different thing. I want to measure the use of resources. I want to check if this method, this layer that do different kind of things, use some specific amount of memory, like 50 megabytes. And you need to declare specifically this annotation. So you combine all these things. The main problem, I will run again this, the main problem with this approach is consume a lot of resources to process the results. So perhaps takes more time to give you some information. Let me show you. Okay. Okay, one of them failed. Yeah, will fail again because the use of my of the query. But you can do this the same. And what happened in the case that you want to check if the insert or the business logic that is responsible to insert a row, check if exists or not. In this case, I will invoke to this insert with behind the scenes check if the city exists or not. So we'll execute one select to the database to check if the city exists or not. And after that, if the city not exists, we'll insert in the database this row. So this is a way to combine to do different things. So I will run just this test because it's a lot to do it. And okay, I have a problem here, and it's connected with the max execution time. Takes more than 1 millisecond to execute all this kind of operation. And this is everything on the live coding. Let's do a recap on the presentation just to finish the exercise. So the best practice is to do this. You always try to create or write tests for a complex query that access to the database. Perhaps in your application there are many of different kind of queries, and it's impossible to create a specific test for all of them. Try to do it with the most complex on inside your application. And in the case that you detect a problem with the performance on some specific queries, try to check with the DBA which is the possible answer or the possible solution of this kind of problem. And run this particular test inside on a pipeline. Of course, it's like a JUnit test, so you can push this test inside your repository, and when the execution of a pipeline when to run the unit test will execute this test, and you will detect as soon as possible that something bad happened with your application. Create the performance test is a good way to detect problems. It's not okay, I don't have the possibility to run all or write all the tests to check everything inside of my application. Okay, it's okay, create a performance test that give you some clues about which could be the possible problems that exist on your platform, and after that try to run or create some specific test in this flow in that flow that have some kind of problems. Define alerts is a good way to detect if something happened in your application related with the performance. And here are some additional resources and to write queries in the case of Java or most of the languages that use JVM. And here are some blogs. So it's time to answer your question. So feel free to ask me anything that you want to know.
That was awesome. And before we move to the discussion zone, there was several questions from Anastasia, and I really hope everybody will be able to join the discussion. Like Andres, you introduced that QuickPerf supports many frameworks, and yeah, the question was like, does it work if the application uses MyBodies?
QuickPerf works in any framework that use behind the scenes JPA. So MyBodies is not the case, but for example, Micronaut have some frameworks that use behind the scenes JPA. Spring Boot do the same, Hibernate too. So everything that use behind the scenes JPA, you can use it in your application.
That is lovely. Yeah, and that is a really enjoyable tool to have. I'm really looking forward to using it as well. And everybody, please leave your comments and leave your feedback for the presentation by Andres. So Andres will have more insights to build up the next presentation to make it even better. So yeah, please let us know, let Andres know what you like and what you didn't like during the presentation. And now let us make a applause for Andres, and let's move to the discussion zone. Thank you. Bye-bye.
Thank you. Bye.